Homework 9, section 5.2, the addition rule complements video 4. Let's talk about something called mutually exclusive events. The definition is pretty straightforward. Two events that cannot occur at the same time. On the board I have three pairs of events, and the question is which are mutually exclusive, which is asking which cannot occur at the same time. Pair A, event A, you own a dog. Event B, you own a cat. Pair B, event A, you roll an odd number, meaning you roll a die. Event B, you roll an even number. Event C, you draw an ace. Example C, event A, draw an ace. Event B, draw a diamond. Think about which ones might be mutually exclusive. Which pairs cannot occur at the same time? Let's talk about the first one. Event A, you own a dog. Event B, you own a cat. Is it possible for a person to belong to both of these events? Yes, I am one such person. I belong to event A, I own a dog. I belong to event B, I own a cat. Because it is possible for these to occur at the same time. Because there exist people that belong to both events, these are not mutually exclusive. But what about example B? You roll an odd number, you roll an even number. When you roll a die, is it possible for these events to occur at the same time? And the answer is no. If you roll a number, it's going to be even or odd, but it can't be both. These are mutually exclusive. Example C, you draw a card. Can it be an ace and a diamond simultaneously? As we've already discussed, yes it can. Since it's possible, since there is a card that belongs to both events, these are not mutually exclusive. Now, before I continue the discussion about mutually exclusive events, I'd like to go to the two that are not mutually exclusive and see if we can come up with a way to make them. For example, if event A was you own a dog, what could we change event B to make it mutually exclusive? Well, if you own a dog, then it is impossible for you to not own a dog. So we could say you own a dog, you don't own a dog, and those would be mutually exclusive. What about over here? You draw an ace and you draw a diamond. Not mutually exclusive, there is one card that would belong to both events. Well, what can I change the second event to? You draw an ace. You could say you don't draw an ace, but compliments aside, let's find a different event. You draw an ace. If you draw an ace, then it's impossible that you drew a king, or a queen, or a 7, or a 3, or anything that's not an ace. So there's a lot of events I could think of for the second one that would make these mutually exclusive. The most generic is you do something, you don't do something, but in this case we could be a little more specific. You draw an ace versus you draw a 10. Those would be mutually exclusive. Now, why do mutually exclusive events get to be a thing? Well, what's the big deal about those? Well, if you have two mutually exclusive events, you can say something about their joint probability. Remember, even though I didn't write it on the board, a joint probability is basically an and probability. The probability of one event and another event occurring at the same time. In other words, occurring jointly. Well, think about it. If you have two events that are mutually exclusive, they cannot occur at the same time. What do you think the probability is of them occurring at the same time? Wait a second, I just said they can't occur at the same time. I know. If A and B are mutually exclusive, then their joint probability, the probability of A and B, Well, what? Well, if they're mutually exclusive, then this is impossible. And if something's impossible, its probability must be 0. Okay, that's a cute little observation. If two things can't occur at the same time, then their joint probability, the probability of A and B, is going to be 0. But what does that get us? Well, you're about to see.